Animals keep evolving into anteaters. Why? Across the planet, unrelated animals from very different branches of the family tree have independently evolved to become specialist ant and termite eaters. In fact, there's even a word for this fascinating phenomenon. Myrmecophagy is the feeding behavior where animals eat ants and termites. So why does this happen? How often has it happened? And who are the brave animals that take on ant and termite colonies? A recent survey, first published in the scientific journal Evolution, compiled the diets for thousands of mammals and mapped the dietary shifts on evolutionary trees. The researchers concluded that strictly ant or termite-eating animals evolved at least 12 separate times in mammals since the dinosaurs went extinct some 66 years ago. That's not just a few cousins doing the same thing. That's multiple orders of mammals, from monotremes to placentals and marsupials, arriving at very similar specializations. So, who are the brave anteater type animals then? You've probably heard of a few of the main ones. The giant anteater, for example, from Central and South America. This textbook sticky-tongued specialist can grow up to 1.8 meters or 6 feet long and weigh 40 kilograms or 88 pounds. It lives in lowland forests and tropical grasslands. It is usually active during the day, but becomes nocturnal near human settlements. Giant anteaters eat up to 35,000 ants per day. The Tamandua or lesser anteater from Central and South America. This anteaters are boreal and terrestrial. They have a prehensile tail for climbing. They nest in tree hollows or in burrows underground. And the silky or pygmy anteater from South America. This tiny animal lives high in the trees and is nocturnal with large eyes. It grows to 45 centimeters long or 18 inches and weighs up to 400 grams or 14 ounces. Its silky yellowish coat matches the color and texture of fibrous seed masses produced by the silk cotton tree or kapok tree. And pangolins from Africa and Asia. They are often called the scaly anteaters, although they are not related to true anteaters at all. These nocturnal animals roll up into a ball when threatened, using their scales as armor for protection. The scales are made up of the protein keratin, like your hair and nails. There are 9 pangolin species, which can weigh from 1 to 3.3 kilograms, and they are around 0.85 meters long. Echidnas, Australia and New Guinea. These are egg-laying mammals or monotremes. These weird creatures even have backward-facing hind feet. The young joey clings to the hairs inside the mother's pouch, where it suckles for 2 to 3 months. The milk is released through pores in the mother's skin, and she does not have teats. Once the joey's spines start developing, the mother removes it from her pouch and builds a burrow for it. Numbats, also from Australia. These marsupials are active during the day and lick up around 20,000 termites every day. They are a dasyuriid marsupial, that is, they don't have a proper pouch for their young, but instead have skin folds to cover their joeys. Aardvark from Africa. Its name literally means earth pig, as it has a pig-like face. The aardvark is a burrowing termite specialist weighing up to 65 kilograms. It travels from 10 to 30 kilometers along familiar paths every night, grazing on ants and termites as it goes. It has a thick hide with little hair. The aardwolf, also from Africa. This shy nocturnal animal looks like a small striped hyena. The aardwolf specializes on eating termites rather than meat. It only weighs 8 to 10 kilograms. It has retained the sharp canine teeth and strong jaws characteristic of hyenas for protection. Its cheek teeth, though, are mere pegs for crushing termites. It shelters in abandoned aardvark burrows. These species are not close relatives in most cases, yet they share a similar diet and many convergent or similar traits. So, what are these similar traits that keep reappearing? Well, they include the following. Long, fast, sticky tongues. These are great for slurping up ants and termites in tight spaces. Giant anteaters, pangolins, echidnas and numbats all use the same trick. The tongues of giant anteaters can be up to 60 centimeters long. Reduced or absent teeth. Biting isn't as useful when your prey is small and swallowed whole. Crushing or grinding can be handled in other ways, for example with muscular stomachs or with stones or gravel in your stomach. Echidnas have keratin pads in their mouths to grind food. Powerful forelimbs and big claws. These are used to rip open nests and termite mounds. Aardvarks and anteaters are especially good at this. These claws are also very effective in defense, or at the very least, in warning would-be predators. Specialized skull or jaw shapes. The elongated snouts and narrow heads help the animals reach into ant or termite mounds. Physiological and microbial tweaks. Adaptations in digestion and gut microbes are used to handle a diet that's low in some nutrients and high in chitin and toxic elements such as formic acid. Detailed DNA and RNA studies, along with multidimensional studies of biological processes, have been completed by scientists. These studies show similar gene and microbiome modifications have evolved in different animals that eat ants and termites from different animal families. These traits are repeated solutions evolved in unrelated lineages to solve the same problem. That is, how to harvest tons of tiny biting insects efficiently. This is called convergent evolution. So, why do animals specialize in eating ants and termites? Well, for one thing, there are so many of them. Ants and termites also form dense, concentrated masses in nests, trails, and foraging columns. Today, ants and termite species number over 15,000 species. A global survey estimated 20 quadrillion ants on Earth with a biomass totaling about 20 million tons of dry carbon. This is more biomass than all the wild birds and mammals combined. That enormous reliable resource is a powerful selective pressure for animals able to exploit it. Interestingly, ants and termites made up less than 1% of the insects on Earth in the Cretaceous period. It was only in the Miocene age about 23 million years ago that they reached modern levels of around 35% of all insects. Ecologically, ants and termites live in dense colonies. They often can't escape quickly from a broken nest. This makes concentrated feeding bouts worthwhile despite defensive bites or acid sprays. These specialized ants and termite predators have evolved ways to minimize the cost to themselves. Their rapid tongue flicks and thick skin or scales protect them. Many have also developed selective foraging habits that leave colonies more or less intact, and ants and termites less defensive or still busy mobilizing. This significantly reduces the bites the predators obtain in hoovering up the insects. Surely there are trade-offs or risks to becoming a specialized anteater type animal though? Well, yes, there are. Specialization does have costs. Relying on a narrow food supply makes species vulnerable to habitat change, invasive species, or declines in the insect resource. That's one reason pangolins, numbats, and some other myrmecophages are now conservation concerns. Habitat loss and human pressures can quickly threaten animals that need particular habitats rich in termites or certain ant species. Also, some adaptations, such as their loss of teeth and digestive tract adaptations, are hard to reverse. Once a lineage evolves to be highly specialized, it can rarely go back. Historically, as ants and termite numbers exploded, this wasn't a problem. Indeed, these anteater animals are regarded as keystone species. Without them keeping these tiny, busy insects in check, whole ecologies would be overwhelmed and would subsequently fail. But now, with us changing things so quickly, chances of these animals being able to evolve into something else equally quickly in response to reduced food sources or vanishing habitats is non-existent. Evolution takes time. Well, no discussion on these anteater type animals would be complete without a few did you knows. So here goes. Anteaters and aardvarks don't eat whole colonies. They mine nests and move on, leaving some insects behind so the colony can rebuild. That's a surprisingly sustainable foraging pattern. Tongue speeds are also astonishing. Some anteaters flick their tongues 150 times per minute to collect hundreds to thousands of insects in a short feeding session. This is done by a whole system of muscles that control movement of the tongue. Gut microbes and genetic changes, such as in enzymes that handle chitin and nitrogen waste, turn up again and again in unrelated anteater animals. So evolution operates at the level of genes and microbes. Well, so what does all of this tell us about evolution? Myrmecophagy is a neat case study in convergent or contingent evolution. On one hand, unrelated animals repeatedly arrive at the same morphological and physiological solutions to a problem. This is what we call convergent evolution. On the other hand, most mammals never evolved into anteaters, despite the large ant and termite numbers. This reminds us that the history of a particular lineage, and chance itself, also shape evolutionary outcomes. So contingent evolution suggests that historical events and chance occurrences are so crucial that if evolution happened over again, it would likely lead to vastly different outcomes, making the specific evolutionary path unpredictable. So together, these forces produce the rich, repeatable, and yet still surprising tapestry of life that you can watch and study today. Isn't that so fascinating? Well, that's it for this video. If you found this video interesting, please like and subscribe. And if you want to know more about fascinating animals, check out the video on animals with chlorophyll or on the one with fascinating animal adaptations. I'll leave the links up here and down in the description below. Until next time, enjoy!